All right, mathletes, here we are looking at geometric sequences and geometric series. So a geometric sequence can be attained by multiplying one term to the previous term. Okay, so we have repeated multiplication. That term that we keep multiplying to each time, okay, is going to be our common ratio. Okay, so if we look at this sequence, we can see from 2, if we multiply it to 3, we get our next term, 6. And then we can see if we take 6 and multiply it by 3 again, we are going to get 18. If we take 18 and multiply it by 3 again, we're going to get 54. So when you write, if you're ever given a sequence and you want to test to see if it is geometric, what we want to do is see and make sure there's a common ratio. Okay, so in order to do that, you take un plus 1, which is a term after the previous term. So if you look at those for, let's say, 3 or 4 of the terms you have, and they all give you rise to the same common ratio, then you can say that it's a geometric sequence. For instance, if you do 6 over 2, that is 3. If you do 18 over 6, that is 3. And if you do 54 over 18, that is 3. Because these are all the same, we call our R value, our common ratio, 3. Okay? So, for a geometric sequence, the first terms u1 and the common ratio r, the general term of the nth term is un of the first term, u1, times r to the n minus 1. So consider this sequence. We have 16, 8, 4, 2, and 1. So first part on A, we want to show that this sequence is geometric. So in order to show it, we're going to take the previous term and multiply it by the one before it, or the second term multiplied by the one before. We see that this will simplify to 1/2. We do it for the next grouping. So we have 4 divided by 8. Again, that is 1/2. We can do it for the next one, and we have 2 divided by 4, and that simplifies to 1/2, and 1 over 2, which is 1/2. So being that these are all 1/2, okay, that is showing that the sequence is geometric. Okay, and also that tells us what our R value is. So in B, okay, find the general term. So I'm going to use our equation to find our general term. So remember that 16 is our u1 term. So using my formula, I have u to the n is equal to u1, the first term, which is 16, times my r. Well, I found my r in my previous step, and I get r to be 1/2. And then I have n minus 1, where n is the term that you're trying to find. Okay, so there's B. So C is going to ask us to find the 10th term as a fraction. So that's saying for n being equal to 10, find u to the 10th. So using my formula from above, I'm going to get 16 times 1/2 times 10 minus 1, which is equal to 16 times 1/2, and I get 10 minus 1 is 9. Okay, so if I use my rules of exponents here, I know that this is going to be equal to 16 over 2 to the 9th. Well, 2 to the 9th is 512 and 16. Well, the nice thing is 512 is divisible by 16, so I get 1 over 32 as my simplified term. Okay, so we got our next example here. So if we have k minus 1, k plus 2, and 3k are consecutive terms of a geometric sequence, find the possible values of k. So using our definition of a geometric sequence, we know they have to have a common ratio, meaning that k plus 1 divided by k minus 1 has to equal r. And we also know that, sorry, this was k plus 2. And I also know that 3k divided by k plus 2 has to equal r. So by substitution here, okay, and equating r's, I can generalize and say if those two r's have to be the same, therefore k plus 2 over k minus 1 is equal to 3k over k plus 2. Notice, at this step, we cannot solve for k because we have two variables. We have k's and we have r's. Okay? But as we do our substitution and equate our values, now we have a single equation that is only with k as variables. So we should be able to solve that. So because I have ratios here, I'm going to cross multiply to undo my division. Okay? So I'll do this on the left side. So I get k plus 2 times k plus 2, which is equal to, this is my right side, I get 3k times k minus 1. So distributing this, I'm going to get k squared plus 2k plus 2k again plus 4 is equal to, distributing this, 3k squared minus 3k. So at this point, I recognize I have a quadratic. Okay, and that quadratic, well, to solve a quadratic, I need to get it set equal to 0. So I'm going to get my left side equal to 0, so I'm going to minus k squared. This I'm going to group together. That's 4k, so I'm going to minus 4k. And I'm going to minus 4. So I got to do that to both sides. So minus k squared minus 4k minus 4. So getting that all together, this left side is going to be 0. 3k squared minus k squared is 2k squared. Minus 3 minus 4 is minus 7k minus 4. So now, looking at this quadratic, I'm going to try and solve by factoring because I find that to be the easiest. So using my diamond method, a times c, I get 2 times negative 4 is negative 8, and my b term's negative 7. So what two terms can be multiplied together, be negative 8, and add to negative 7? Well, that is going to be negative 8 and 1. Okay, so I'm going to rewrite my middle term with my quadratic using negative 8 and 1, and then factor. So I get 0 equals 2k squared minus 8k plus 1k minus 4. Factor these, the first two groups, so they both have a 2 in common, and they both have a k in common. I'm left with k minus 4. Okay. Over here I have k minus 4, so I'm just going to factor out a 1, and I get k minus 4. I know I'm doing this right because I have these two values being the same, and I get this is equal to k minus 4 and 2k plus 1. Well, what are the solutions to this to be equal to 0? Well, either the first part's 0, so that gives me a k equal to 4 would make that 0. And from the second part, if I get that equal to 0, that's k equals negative 1 over 2. So those are the two possible values of k in order for this to be a geometric sequence. Let's look at another example here. A geometric sequence has u2 to be negative 5 and u5 to be 40. Find its general term. Okay, so using my formula, okay, I know that u2 is equal to negative 5. Well, that comes from the first term times my common ratio, okay, times n. Well, in this case, remember this represents our n, so the 2 minus 1. Okay, there. So if I simplify this a little bit, I have negative 5 equals u1 times r. 2 minus 1 is just to the first, so something in the first, I can just leave that blank. So again, I have one equation here, but I have two unknowns, so I can't solve that alone. So I want to use the second piece of information. So I know that u to the fifth is equal to 40, okay, which is equal to my equation, that is u1 times r times n. Well, again, for this one, n is 5, okay, minus 1. So I simplify this, I get 40 equals u1 times r to the fourth. Okay, so now, again, I have an equation, two unknowns, but I have two equations and two unknowns, so I got to solve this system of equations. Okay, so since there's not addition or subtraction here, I'm going to try and do it by substitution. So on this left side, I'm going to get this solved for u. So I'm going to get u by itself, so divide by r on both sides. So I get negative 5 divided by r is equal to, well, the r's cancel out, u1. Okay, so then I'm going to take this as u1 and plug it in to my equation over here. Okay, that'll give rise to a new equation, and I get 40 is equal to, well, u1 I'm going to write as negative 5 over r times r to the fourth. Using my rules of exponents, r to the fourth divided by r is just going to be r to the third. So I have negative 5, r to the third is equal to 40. Divide both sides by negative 5 to get r by itself, or r cubed by itself. And I get negative 8 is equal to r cubed. We'll undo something that is cubed. That's right. I'm going to do my cubed root. And using my calculator or just some good math, I know that the cube root of negative 8 is negative 2, which is equal to r. Okay, so now that I have the r, I still need to know what the first term would be. So if I know that u2 was negative 5, okay, I need to know that, and my common ratio is that is negative 2. So then for u1, I know that u2 divided by u1 is equal to r. Okay, that's how we find our common ratio. Well, u2 is negative 5. I don't know u1, so I know my r from here is negative 2. Okay, so I multiply both sides by u1, and I get negative 5 is equal to negative 2 times u1. And I divide by negative 2. And I get 5/2 is equal to u1. So putting those together, I get my final term, my general term, un is equal to u1, which is 5/2, times my r, negative 2, times the n minus 1. All right, so there's that. All right, next we are going to talk about our geometric series. So a geometric series is a sum of terms of a geometric sequence. Okay, the sum of the terms of the geometric sequence. So instead of just having terms and having commas here, right, when we have a geometric series sequence, the series is saying we're going to add these terms together now. Okay, so we're given a formula. I'd make sure I have this down in my notes because I'll be using it for problem sets. Okay, for a finite geometric series, that means we're going to stop somewhere. We can use either one. Notice, it's easiest to use this formula, the first one, if r is greater than 1. Okay, and it's easier to use the second formula if r is less than 1. If you forget that, though, you can use whatever one and it will still work out. You just have to be careful with your signs. Okay, so notice for both the equations, we need to know the first term and the r term. Okay, so find the sum of this. Well, first I need to find my common ratio. So if I do 6 divided by 3, that's 2. I can do 12 divided by 6, and that's 2. And I can do 24 divided by 12 and show that that's 2. So because those are all 2, I know it's a geometric series, and my r is equal to 2. Okay, well, I need to then I already know my first term. That's u1. So then I have what I need to do that. So because my r is greater than 1, I'm going to use the first one. So I'm going to do the sum of the first 10 terms is equal to u1, which was 3, my r, which is 2, my n, which is 10, minus 1, over r, which is 2, minus 1. Okay, if I use some math here, I'm going to get in my calculator, I'm going to get 3 times 2 to the 10th minus 1 is going to be 3,069 divided by 1, well, it's just going to be 3,069 is the sum of the first 10 terms of that sequence. Okay. Next example here is if we are going to look at a infinite geometric series, meaning this is going to go on forever. So we have a set of terms, but the dot 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 means we're not going to stop. Okay. Well, we can only really do that for one type. If our r value, our common ratio, is greater than 1 or less than -1, meaning its absolute value is greater than 1, we say the series is divergent. As we get those numbers larger and larger and larger, it's never going to be a divergent series, meaning it's going to keep adding larger and larger numbers, and it's going to go to infinity. Okay, but if we have an r value that's in between -1 and 1, we say that that series is convergent. Okay, meaning it converges at a single value. Okay, so and we use a formula, sum equals u1 over 1 minus r. So for this example, okay, we can find the sum of 2 plus 1 plus 1/2 plus 1/4, so we can get our common ratio. So we do 1 divided by 2, which is 1/2, and we're going to get 1/2 divided by 1, which is 1/2. So I see that my r is equal to 1/2, meaning it's going to be convergent because 1/2 is less than 1 and greater than 1/2. So we can find the sum of this infinite series, even though this goes on forever. Okay, this series, it will converge to a single sum. Okay, so our sum is going to be equal to our first term divided by 1 minus 1/2. Well, 1 minus 1/2 is 1/2, and dividing by something is the same thing as multiplying by the reciprocal, so 2 times 2 over 1, which is 4. So this sequence will never get bigger than 4. It will converge to 4. Okay, that ends our notes tonight. Please highlight any questions you might have and bring them to class tomorrow.